As you saw in the introduction, today we will be learning about exponential functions. Here are some examples or characteristics of exponential functions. A function that can be expressed in the form f x equal a b x, or anything like this and it's positive is called an exponential function. Exponential functions with positive values of x are increasing one-to-one functions. And graph example of exponential function is this is the best graph example of exponential function, which start at 0. Now we are going to build an exponential model through the points 2, 6, and 5, and 48. Over 2. It's y equal a b x. To the x. What we are going to do is set up a model for each point. The 2 is an x value, and the 6 is the y value. To plug those in, we get 6 equals a b to the 6. And do the same with, you would do the same with 5 and 48, which would look like 48 equals a b to the 5 to the 5th. To the what we have now is two equations with two unknowns, a and b. We can solve this with a substitution or elimination with exponential because we have a common ratio. We do this with dividing, so we divide both sides of the equation, which will give us 6 over 48 equals a b to the 2nd and a b to the 5th. So we have 6 over 48, which reduces down to 1 over 8. And then here we have to do our elimination. 6 over 48 equal a b to the 2nd and a b to the 5th. We eliminate our a's because the a's cancel now. We have 6 to the 2nd over 6 to the 5th. B squared over b to the 5th. Two things of the same base. Their exponents subtract, so that's 1 over 8 equals b minus 3, or to the 3rd, to the negative 3rd. So now we have enough information to solve for b. What we can do to solve this is raise both sides, which would look like 1 over 8 then 1 over 3 equals, open parentheses, b minus 3 negative 1 over 3 to the negative 1/3, because it then makes it just b. We could leave it this way or calculate it with a calculator. Take the reciprocal, open parentheses, 8 1 over 3 equals 6, and the cube root of 8 equals 2 equal b. And keep in mind, our base can be anything. So now for a model, we have y equals a second x. We are going to plug in either one of our points for x and y. Plug in 6 for y. It would look like this. So we have 6 equals a times 4. Then you divide. So you set it up and 6 equals 8 times 4. Both sides by 4. I get, divide both sides by 4. I get 3 over 2 equals 6 over 4 equals 8. Y equals 3 over 2 times 2 to the x. You can check this by graphing it using the points. Another example is 1 over 2 to 7 equals a to the 5th x minus 7. Rewrite 27 as 3 cubes 9. So we get, rewrite 27 as 3. 3 equal, parentheses, 3, 32. No, 3 to the second. Sorry. Then 5x minus 7. 9 could be written as 3 squared, and we still have our 5x minus 7. On the left side, we bring our denominator up by 3, negative 3 equals 3. Multiply 2 times 5x. So now we have 3 minus 3 equals 3. 10 to the x times negative 7 would be 3. It would be 3 negative 3 equals 3 10x minus 14. Now we can set the exponents equal and solve. So we would get negative 3 equal 10x minus 14. Then I could add 14 to both sides. That could give me 11 minus 10. Now I can divide both sides by 10. 10. That is how you solve for an exponential function, and that were some examples in case you needed a written example of how to solve for an exponential function.